Hi, I'm Maria Luisa, and today I will present the topic of my research physics-based deep learning for groundwater prediction. Every day, before stepping out of my house, I check the weather forecast. In this way, I know if to take an umbrella or not. At the same way, policymakers constantly need to check water models in order to know if there is too much water, leading to floods, or too little water, leading to drought. Based on the results of the model, they can know if to take any actions. If, for example, there is a risk of floods, they can decide to evacuate people or to divert the water. There are several of these water models, all linked together. The groundwater model is the model that predicts the amount of water in the ground, and by doing so, it predicts if there will be a drought, and it also provides the input for the flood model. The groundwater model is based on our scientific understanding on how water behaves and moves in the ground. And eventually, this is described by physical laws. When we're running the groundwater model, we are solving these physical laws. However, the current model is quite slow, so it can take from hours to even weeks for a model to produce results. But we live now in a time of artificial intelligence, the so-called fourth revolution, and we don't need to wait for so long. With deep learning, we can solve these models in a matter of milliseconds. Deep learning is a very powerful technique. It's used in many applications around us, from series voice to photo tagging to self-driving cars. But in the scientific world, it has been quite criticized because it requires a lot of data, which sometimes are not available, and because it's quite difficult to interpret. Also, its nickname, black box. But here is the idea. With physics-based deep learning, instead of with data, we feed the deep learning model with physical laws. In this way, we don't need the data anymore, and we exactly know what's going on under the hood. It's thanks to this blending of artificial intelligence and science, thanks to the combined effort of a scientist and a robot, as depicted in the image, that we can run these same models, the same groundwater model, but then very fast. And so eventually our policymaker can know on time if there will be a drought or a flood. And eventually, if they also need to take an umbrella before stepping out of their house.